My name is Harrison Leary, and this is my Physics 2 Lab 2. So for an introduction, the goal of this lab is to repeat the experiment from the previous lab, the charge tape lab, but with a more accurate model of the electric field. And specifically, that will be treating the tape as a line rather than a point charge, which produces a completely different model and results. And so the results of this experiment were, again, that the force of gravity is equal to the electric force, but this value is 1.962 times 10 to the negative 3 newtons, and the charge of the tape was 1.774 times 10 to the negative 8 coulombs. So the physics principles we used are the electric force, as seen here by kqqq over r squared times r hat. And also we have the electric field, which is found as the integral of dE, where dE is k dq over r squared times r hat, and dq is lambda dx. And finally, the gravitational force is mg in the j hat direction. So some of the data and calculations, we use the same constants and values as lab 1. So this was the length of the tape being 0.2, the distance of attraction being 0.038, and the tape mass being 0.000245. So then for our model, the assumptions we made were that the tape is a line charge with evenly distributed charge, otherwise this model would not work. And some discrepancies in value are that the measurements of the values led to slight discrepancies between the electric force and the gravitational force, as seen by the electric force being 1.96147 times 10 to the negative 3, and gravitational being 1.96200. So then for the code, here are all the things that I changed from the starter code. So we have the inserted mass and charge of the tape, then the electric field equation here, which is just a direct version of the previously mentioned physics principle equation. And then for the vectors, we used the separation distance of the tape to create the top tape and bottom tape vectors. Then the scales were adjusted accordingly so that the model was visible, and the forces were calculated based on the other equation previously shown, the E equals the integral of dE equation. So for conclusion, if you had modeled each of your tapes as a single point charge rather than as a line charge in this lab, what would the difference in the models and the values be? So what we found was that the charge of the tape in this lab was much larger than in the previous lab where it was treated as a point charge, and that is because we are using a collection of charges as our simulation here rather than one singular point charge creating this force. And logically that makes sense, because if you have a line of charges, they're going to have more of an impact on another object, this being the other tape, compared to just a singular point charge if we are using similar conditions and similar charges in our estimations. And so do these estimates differ? Yes. Which value is likely to be the real value? The value from this experiment, where it is treated as a line charge, is much more likely to be accurate because a tape is much more similar to a line charge than a point charge. And that is all. Thank you.